Hello, in this video, we're going to be talking about limits. Now, calculus is interested in about shoving two things together that we're not allowed to put together. So we want to kind of play the I'm not touching you game, similar to what asymptotes do, where we get really close to touching. But we don't ever quite get there. And we want to see where are we heading towards as we reach a particular value. That is what a limit is checking. Here are limits. So a limit is the value a function is moving towards as the value of x approaches a particular value. So it doesn't evaluate the function at that particular point. It's just seeing where are we moving towards? What sort of direction does this function seem to be going towards as we reach a particular value? So in this thing right here, it would be read as the limit as x approaches c, so that's down here, of f of x equals some number, L. That's our limit. Now, not all functions have limits everywhere, so a function's limit could not exist, so the limit does not exist. We would just write D and E. In order for a limit to exist, is we make two kind of like little mini limits. So we put like this little plusy thingy and a little minusy thingy, kind of like exponent thingies. And what they mean is this is as x is approaching c from the right versus approaching c from the left. So we see if the two directions of where the function is moving, if they're coming towards the same value. If they miss, then the limit doesn't exist. But if they meet, then we have a good limit. So in this problem, we're checking, okay, what is the limit as x is approaching -1 from the right? Yeah, we know it's from the right because it's got this little plus thingy there. So as we move towards here, as our x value gets closer to -1, so at this -1/3, -2/3, -8/9, what is that y value spinning out? So it's like 1/3, 2/3, 8/9. It seems to be up here at +1. So it seems to be heading towards that point right there. The y value the function is spitting out is 1. So this statement is true. If we check this one over here, what is going on as x is approaching -2 coming in from the left? Approaching 2. We approach 2 coming in from the left. So as our x value is 1/2, 1.7, 1.8, 1.9, it seems to be spitting out a y value of 0, a y value of 0, a y value of 0, y value of 0, until it hits 2. We're not going to get quite to 2, but we're going to approach 2. But it seems to be doing 0, 0, 0, 0, 0. So we could assume that as x approaches this, it's not 2. This is false because the actual value of the limit is 0, not 2. Oh, we got people arguing again. Oh, they're arguing. This person's like, the limit as x approaches 0 of f of x is 1. And somebody else says, no. The limit as x approaches 0 of f of x is 0. I don't know which one it is. We got to figure it out. Well, but to start that, I want to first say, what is just the function equaling? Not the limit, but what does the function actually do? This doesn't help us determine the limit, but it is still kind of nice to know, to understand that we're not talking about what the function actually does there. We only care about where the function is heading towards as it approaches that point. So f of 0 is this filled in dot right there. It's at 1. As we come in from the left over here, we can see that it's heading down towards 0. As we come in from the right, that's what this little plus thing means. As x approaches 0 coming in from the right, it is also heading towards 0 because they're both heading down towards this spot. In fact, they're both equaling the same value. These two things are true. Since those two things are true, that the two values are equal, we do have a limit at this point. The limit at this point is this value. It has to be that 0. So this person was right. This is true, that the limit as x approaches 0 of f of x is 0. This person is false. They may have been confused in thinking about like, hey, that is what the value the function spits out at 0. It is not, however, the limit at that point. That's our introduction to limits. This is just the introduction to limits. We're going to be playing much more with limits to get a better idea. This is just to get you started and thinking about limits. The important thing I want you to take away from this video is that limits are just where we're heading towards, not where we actually end up when we are approaching a particular value for that function, and that the right and the left-hand limits have to match up in order for us to get a full limit at that point. Thanks for watching. Goodbye.